All right, day 4b, the second part. We're going to continue on with the polar stuff. Today is all about, mostly it's just going to be substitution and simplify. Okay, so first off, it says go to Desmos or go to a polar mode and graph this. So think of this as r is a function in terms of theta here. So as I put new thetas in, r is going to change. And what will that look like? So first off, go to your calculator, make sure this is down here. First off, make sure it's in radians for now. And then over here, make sure that's in polar. Put it in polar form. Okay, then go to y equals, and I got 4 cosine theta written in there. Let's take some time to put that in. And then, so 4 cosine theta, hit graph, and it'll make a circle here. And if you see, even though it's not drawn to scale, it is a perfect circle. It is right 2, left 2, up 2, down 2. So it's a circle with a radius of 2. So if we're going to graph that, just real quickly here. Let's see, 1, 2, there's the center. 1, 2, up 2, down 2. So it looks something like this. Not the best circle I've ever drawn, but so it's a circle with a radius of 2. Again, make sure you're in polar form and make sure you're in radians. Okay, and now if I want to put this in rectangular form, so when I put it in rectangular form, the quickest way to do that, notice there's no r on this side. Okay, so I'm going to make this, I'm going to multiply both sides by r. Side of r squared equals 4r cosine theta. And we learned yesterday, r squared is the same thing as x squared plus y squared. And r cosine theta is x, so equals 4x. Okay. And now, to get this to look more like something we've ever seen before, I'm going to bring the 4x to the other side, so x squared plus 4x. I'm going to leave a little gap here and put y squared equals 0. And when we write circles, we want to have x plus or minus something squared and y plus or minus something squared. Well, the y is good. The y is squared, but right now, what would I need to add to this to make it a perfect square trinomial, or perfect square trinomial, which in other words would be a binomial squared. So think if I were going to FOIL this, what number plus itself equals 4? You might remember this as being called complete the square. So fast way of doing this is, what's half of 4? It's 2. Now it's 2 squared, it's 4. So I add a 4 on the left side, which means I got to add a 4 to the right side. So this right here is the same thing as x plus 2 squared. And on the right side, I have 4. And if you remember, the h here, the h is a 2. I'm sorry, I messed up. This is supposed to be a minus. So minus, which means this is going to be a minus. Still, squared is going to be 4. So I'm sorry, so half of negative 4 is negative 2. Negative 2 squared is 4, so I still add 4 to both sides. So h is the number you're subtracting from x. K is the number you're subtracting from y, which would be 2 and 0. That's where the center of the circle is. And then this r squared, this equals r squared, so the 4 is 2 squared, and that's a radius of 2 going all around there. 2 squared is 4. Now I give you this picture. Now it's supposed to be just a straight up and down picture. It's a vertical line, which would be x equals 2. Okay, so that's in rectangular form. Now if I want to convert that, okay, what I'm going to do is any x I see, I'm going to replace with r cosine theta. So instead of x equals 2, I'm going to have r cosine theta equals 2. And for polar form, we have, and when we're doing polar equations, r is by itself. Okay, so if I get r by itself, I divide both sides. So r equals, this would be 2 divided by cosine theta. Now, if you want to graph it and check it, you want to leave it like that. So I'll say this, or r equals 2 secant theta, but you don't have secant on your calculator, so you might want to leave it as 2 divided by cosine theta. Okay, so if you put that in the calculator, so 2 divided by cosine theta and hit graph. And there's a vertical line at x equals 2. Now, this guy here, we're given this, and I want to make an adjustment here. This doesn't work unless that's a 13. Just make that a 13 instead. So that's a misprint. We're not going to make you, or we don't need to learn what to do if that equals 16. So if I were to graph this guy, it's centered at 2, -3. Because h and k, this would be minus -3. So that's a -3 down 3. There's a circle, and the radius is about 4. So the square root of 13 is about 4. So we're going to go up 1, 2, 3, and there's 4. So about 4, but a little bit less. Down 4, 1, 2, 3, 4, but we're going to a little bit less than that. And then right, 1, 2, 3, 4, a little bit less than that. 1, 2, 3, 4, a little bit less than that. If you graph this guy, it actually does go through 0, 0, which just kind of makes it nice. It's supposed to be a perfect circle, but my drawings are terrible. So if I had a real plane in there, it might be easier to see. Now, to convert that back, okay, so if I want to make this in polar form, I don't need the graph. I can cover that up. Multiply these out. So I'm going to FOIL these out. So x squared minus 4x plus 4 plus, and then y plus 3 squared would be y squared plus 6y plus 9 equals 13. First off, I'll put the x squared and y squared together. So x squared plus y squared, I'll put them together because x squared plus y squared is r squared. I can do a simple a substitution there in a second. And then minus 4x plus 6y. And the 4 plus 9 is 13. So they wipe each other out. If I subtract 13 from both sides, I get equals 0. Now, x squared plus y squared equals r squared. Minus 4x is the same thing as r cosine theta. Plus 6, and then y is the same thing as r sine theta. So that's the trick right there. That's a substitution. Anytime you see x squared plus y squared, put r squared in. Anytime you see an x, put r cosine theta. Anytime you see a y, put r sine theta. Okay. Now, I got 3 terms on this side. They all have an r in them, so I'm going to take an r out. So r either equals 0, which if r equals 0, that's the origin, which we don't really know that yet. If we were to graph this, if we graph this on Desmos, you'll see it goes through 0. So that's a single point. So when r equals 0, that's a single point. That's also on the graph, so I don't need to worry about that. Or r equals, and bring all of this equals 0, bring it all to the right side. So if all this equals 0, that'd be plus 4 cosine theta minus 6 sine theta. Okay, so let's put that on the calculator and just verify, is it the same graph? So this would be 4 cosine theta minus 6 sine theta. You'll see it is a circle. The center is at 2, -3, and it goes through the origin, and that's everything I just graphed right here. So they're the same thing. Okay, so I'll flip this guy over. Now let's just kind of throw out the graph. Let's not worry about the graphing part. Let's just do the algebraic part. So if you're converting from rectangular to polar, then anywhere you see an x squared, y squared, put an r squared. Anywhere you see an x, put an r cosine theta. And anywhere you see a y, put an r sine theta. So you're going to substitute to convert it. So right here I see an x squared plus y squared. Replace that with an r squared. So r squared equals 81. That means r equals 9. That's it. If you graph that, because this right here would be a circle centered at the origin, because h and k would be 0 and 0, because you're not subtracting anything from x and y. So it'd be centered at the origin, and it has a radius of 9, because this is r squared. Well, here r equals 9. So if you graph both of these, you get the exact same answer. Over here, anywhere you see a y, plug in r sine theta. So r sine theta equals -5. And we want to get r by itself. For polar form, we always want r by itself. So divide this over. So this would be -5 over sine theta. You can leave it like that if you want to check it. I'm pretty sure that in Math Excel that is okay. You could, however, call this -5 cosecant theta, but this is the one I think Math Excel is going to ask you to leave it in terms of sine and cosine. Now going the other direction, we have to do maybe a little bit of trickery with it, because r equals 8. So that means it's kind of basically it's a circle centered at the middle with a radius of 8. Well, anywhere you see an r squared, we can plug in an x squared plus y squared. Well, the problem is I don't see an r squared in there, I just see an r. So what I'm going to do is I'm going to multiply both sides, I'm going to square both sides. So I'm going to square both sides, that way I do have an r squared. And now r squared is x squared plus y squared. Right there is a circle centered at the origin, because I'm not subtracting anything from x or y. And r squared equals 64, which means the radius is 8. So this would be in rectangular form. Here, this sort of resembles something we did on the front. We did a problem on the front where we had to, this guy here, we had to multiply both sides by r. That's because there's no r on the right side. We're going the other direction anyway. So there actually is an r cosine theta already there. Remember, r cosine theta is x. So I'm just going to replace that with an x equals 6. If you graph this on Desmos, well, you actually have to divide that over. It'd be r equals 6 over cosine theta. And then you graph x equals 6. They're both going to give you a straight up and down line. 1, 2, 3, 4, 5, 6 over. Like that. And then this guy here, I want to get in rectangular form. So first off, I'm going to rewrite this as -5 over sine theta. Bring the sine over, so it'd be r sine theta. And the reason why I did that is because r sine theta is y. So I'm going to replace that with a y. So if you put this into Desmos and then put this into Desmos, it'll give you the exact same line. Okay, you can't do that on your calculator at the same time because one's in polar and one's in rectangular. In Desmos, it does it. So they're both going to give you a horizontal line 1, 2, 3, 4, 5 down like that. Okay, so kind of a simple day. Obviously, the Math Excel, you have to think a little bit, but just think how can I get these conversions in there? Whether you're going one way or the other, just use your algebraic skills to figure out what direction you're going.